Welcome back to our session. We're still talking the use of acids and bases, but at the moment we start talking about uses, we also think about the practical component in terms of applying these reactions between acids and bases, okay? Now, we are going to look at, indicators, as a way of us, keeping track of what happens in a reaction between acids and bases, be it a neutralization reaction. And we'll also try and discuss in this segment some of the important aspects of a technique that is referred to as a titration. Right, okay? So the key terms, again, that we want to focus on, we shall be talking about indicators as substances, okay? And that are used to keep track when an acid-base reaction takes place. And then a titration is a technique, right, that is used to actually determine an unknown concentration of a substance using an acid-base reaction. You can think of it in terms of a neutralization reaction, it's still okay, right? Okay, now, what are indicators, right? I think the term indicator, it explains itself. Okay, like you're driving, what do you use an indicator for? To show your intention, right? So in the context of, acid-base reaction, we need to check at some point or the other as the reaction is still proceeding or progressing, at what point do we have neutralization, So an indicator as a substance serves that, type of a role in an acid-base reaction. But let's try and understand exactly what that entails, right? Okay, so indicators, they provide a practical way. So the moment we say practical, in our science, we are thinking now of experiments, okay? All right? So think about that. They always, because science is a hands-on type of a subject, so we will conduct experiments to verify existing facts, to discover new things in investigation. But what do indicators do? They provide a practical way to determine whether a sample of a substance is an acid or a base. What that simply means is it's straightforward. It says that given a sample of an unknown substance whose identity we don't know, we can determine whether this sample of a substance is either an acid or base by making use of an indicator. Okay, that's what it simply means, right? So it says here, an indicator is an organic dye. Okay, this is the chemical composition of an indicator because it is a substance. So this is an organic dye that is able to change color based on the level of acidity or alkalinity. So this has a lot to do with pH, as we have demonstrated in the previous segment in terms of the measuring pH of different samples of substances, okay? So indicators are, in their nature, weak acids or bases. Because in other words, this tells us about the extent at which indicators ionize or dissociate, right? Okay. Now, here are practical examples of indicators that are very common in acid-base reaction. The first one that we have is bromothymol blue, right? So bromothymol blue is an indicator. Its color in the presence of an acid, if we add a few drops of bromothymol blue in a sample of an acid, the color change that we observe is yellow, okay? While if we add a few drops of bromothymol blue to a solution that is at a neutral point, the color is pale green. What is of particular interest to us is that if there is a neutralization reaction and then we've added a bromothymol blue in that reaction, what happens is for us to get an indication as to whether this reaction has reached a point where the two substances are neutral, where they are reacting in a vessel, then that color change into pale green is what bromothymol blue does, right? And then if we place a few drops of bromothymol blue in a sample of a substance which is a base, the color is blue, right? So very, very important there, okay? And then the other one is phenolphthalein, okay? Phenolphthalein, in an acid, it is colorless. It is demonstrated in this case, right? And then in a base, it is pink in color, right? So these are different indicators. And then also have multiple indicators that are available. So one of them is also methyl orange. So methyl orange is the name of the indicator. In the presence of an acid, methyl orange will be red in color. At the neutral point, it is pale orange, right? And then in the presence of a base, it's got a yellow color, right? Now let's look at a titration as a technique, right? So titration is a technique for determining the concentration of an acid or base. This concentration is actually unknown. So we want to use this technique of titration to determine an unknown concentration of an acid or a basic solution. So this is in the context of a reaction between an acid and a base. One of the two, we know its concentration, the other one, we do not. So this process depends on finding the point at which the indicator changes color. Right, we've made examples, in terms of some of the indicators that one may make use of in an acid-base reaction. So if we are to determine the unknown concentration of one of the two, either an acid or a base in a neutralization reaction, would make use of an indicator. So we'll keep track in terms of quantities, that is volume, concentration, and a whole lot of issues. But now, the main thing is that the role of the indicator is to show us when a reaction has reached neutralization, right? Okay, and then here is the setup in a titration, because we say a titration is a technique. So a technique has a lot to do with the practical, right, component of our subject. All right. So practically, this is how you would set up the experiment for a titration. So you can see the burette is calibrated. So that is our burette. Okay, that's our burette. Okay, so this burette is calibrated from 0 to, in this case, 100 cubic centimeters or milliliters. So whatever comes into the conical flask, we can be able to quantify, the volume of whatever is in the burette, be it the acid or the base. And then we've got our conical flask, which is also calibrated. So this is the general setup that you actually have when you conduct a titration. And then a dropper is what we use when we add the indicator, right? So we'd use a dropper to add an indicator into the reaction vessel. And then the stand is just to hold that burette in an upright position so that we can be able to take readings correctly. Right. Okay, here's an example of a titration. We've got hydrochloric acid, sodium hydroxide to give us a salt and water. So the general is that reaction is that when an acid reacts with a base, okay, what do we have? We get a salt as well as water. So that's the generic reaction in as far as an acid and a base. Be it strong or weak, it certainly doesn't matter. So a strong acid, in this case, which is HCl, reacts with a strong base, which is sodium hydroxide. So when it comes to strength, remember, it has nothing to do with concentration. It has to do with the extent of ionization of an acid and the extent of ionization of a base. Complete ionization, strong acid. Partial ionization, weak acid. That's the kind of thinking that we always want to remind ourselves of, right? So bromothymol blue is used to determine the endpoint. So the salt that is formed is actually neutral. What do we mean? Because strong base and strong acid, when they react completely, the salt that is formed is going to be neutral. So we want to qualify that statement to say the salt that is formed here, in this case, which is sodium chloride in that solution, is going to be neutral, provided all the strong acid and the strong base are reacted completely, right? Okay, and then we also have another example of a titration between an acid and a base. But in this case, we've got a strong acid, which is sulfuric acid, and a weak base, which is sodium hydroxide. What do we mean when we say, magnesium hydroxide is actually a weak base? We are saying that magnesium hydroxide, in the presence of water, it dissociates partially to form or to give us a very low concentration of the hydroxide ion. That's what we mean. But equally so, we get a salt and water in that reaction, right? So the salt formed is not neutral. Why is it not neutral? Because we've got a strong acid reacting with a weak base, right? So it makes sense to say that the salt that is formed will be a weak acid, right? Okay, and then also in the above reaction, which indicator do we use? So the choice of indicator that we use is based on the color change and whether the acid and the base reacting in the neutralization are weak or strong. So methyl red in this case is used, and when all the bases have reacted, the color change for this one, methyl orange, is between pH 4 and 4.4 and 6.2, right? So these are just, you know, some of the practical examples, right? Right, we'll take a short break for now. See you shortly.